As we begin this next section, we're going to continue our discussion on sets. I'm going to start with an example so that we can define a few important terms. Our example says, consider the set of natural numbers less than 10. So we want to remember that the natural numbers are the counting numbers. In other words, if I were going to count something, I would start with 1 and then go to 2 and then go to 3. Those are my counting numbers. Those are my natural numbers. So I'm going to go ahead and write those out. It says that the set is the counting numbers or the natural numbers less than 10. So we're going to go 1 through 9. So now we have our set. What I want to do now is define these four terms: universal set, element, empty set, and subset. So the universal set, which we denote with a U, refers to your overall set. It refers to everything that is possible to be in a particular set. So for our example, our universal set contains all of the numbers that we just wrote down. Now, when we refer to an element, we're referring to one particular value in the set. So, for example, I could say that 2 is an element of the universal set. And if I want to say that, then I'm going to write it this way. I'm going to write 2, and then I'm going to write this symbol that looks kind of like an E. That stands for element. And then I'm going to put the U. So this says 2 is an element of set U. Now, what about something like, say, 15? Would you say 15 is an element of set U? Keeping in mind that our universal set in this example is the natural numbers less than 10. So no, 15 is not an element of that universal set. And so if I want to write that mathematically, I'm going to write it this way. I'm going to say 15. I'm going to put my symbol for element, and I'm going to put a line through it. And then I'm going to put the U. So that says that 15 is not an element of U. So you want to be familiar with the notation to say that something is an element or that something is not an element of a particular set. Our next term is called the empty set. The empty set is pretty much exactly what it sounds like. It is a set that has nothing in it. And so you will do the set brackets and you'll leave a space to show that that set is empty. When we talk about a subset, we're talking about a smaller group of the universal set. So for example, if I were to look at the set with the odd numbers, so 1, 3, 5, 7, and 9, I could say that that is a subset of the universal set. Everything that is in this subset that I wrote down here at the bottom is also in the set U. And so to talk about something being a subset, I'm going to use this symbol. So this symbol looks sort of like a C with a line underneath it. And that is the symbol to say that something is a subset of something else. All right, let's determine another subset. So I could have, what about the numbers 2, 3, and 4? Does that represent a subset of the universal set? So we want to check, is 2 in the universal set? Is 3 in the universal set? Is 4 in the universal set? And if they all are, then I can say that I have a subset of the universal set. All right, so with that in mind, we're going to go to an example. Our example says that we have a set E, which is going to have the even numbers. So these are our even natural numbers, 2, 4, 6, 8, and the dot, dot, dot means that it continues. So what we want to do here is we want to talk about how we can write these different sets and elements with the correct notation. So the first part says that we have a set A that has the numbers 6, 12, 18, and so forth. So those are going to be multiples of 6. And so what I want to know is A a subset of E? So if you think about it, E is all the even numbers. So I think I'm just going to sort of jot that down in words just for a second. Now they are the natural numbers, but I'm just to kind of keep it in my head, E is the even numbers. All right, so let's look at set A. Is 6 going to be in set E? Well, yes, we can actually see that one right here. Okay, what about 12? Is 12 going to be in that set? Remembering that set E is all the even numbers and 12 is even, so yes, it would be there. What about 18? 18 would also be in set E because it's an even number. So what we have here is we have a subset of set E. So I'm going to write it this way. I'm going to say that A is a subset of E. Now, our next one, we recognize that notation as the empty set. It is important for you to understand that the empty set is always a subset of any other set. Okay, and we're going to reiterate that as we get into some examples, but I can always say that B, if it's the empty set, is a subset of any other set. All right, let's look at 10. So here we just have one particular number. All right, so one particular number, and notice that we don't have the set brackets. One particular number, what they're asking me is an element. Is 10 an element of set E? Well, remember set E is the even number, so is 10 an even number? Yes, so I'm going to say that 10 is an element of set E. What about 19? Again, no set brackets, so we're just looking at that one particular value and asking whether it's an element. So is 19 an element of set E? Is 19 an even number? And it's not. So 19 is not going to be in set E. Okay, now what is this Z? Do we remember this from the last section? This is referring to the set of integers. And what are the integers? The integers, remember, are your negatives, your positives, and 0, and everything continuing in both directions. So we have a dot, dot, dot on both sides of this. So what about the even numbers? Now, obviously, Z is not going to be a subset of E because Z is going to be a much larger set. The integers are going to be is a much larger set than just this set E that we have with the even numbers. But I think I could write it this way. I think I could say that E is a subset of the integers. All right, so what do we think about that? Does that make sense? So all of these even numbers form a smaller group when we start talking about the integers. All right, what about the R? R is the real numbers. And remember that that's everything. That's your huge group of all your rational and your irrational numbers. So would the even numbers be a subset of the real numbers? And they would. So I'm going to write that E is a subset of R. All right, let's try one more of these examples. This time we're going to do it with letters. So set A represents the letters in the alphabet. All right, and so our first one is asking us to consider not a subset, but 14. There are no set brackets here, so we're just looking at element or not. So if A is the set of letters in the alphabet, is 14 a part of that set? No. 14 is a number. It's not going to be a part of a set that contains only letters. So we're going to say that 14 is not an element of set A. But what about M? Would M be an element of the alphabet? Yes, we know that M is a part of the alphabet, so we can say that M is an element of A. Okay, so now we have this set M that has a bunch of different letters that spell out math is fun. So because we're talking about a set, the question being asked is that a subset of A or not? So again, think about your set A. Your A contains all of the letters in the alphabet. So it contains A, and it contains B, and it contains C, and it contains everything until we get to Z. So does it contain M? Yes. Does it contain A? Yes. Does it contain all of these letters in M? And because it does, then we can say that M is a subset of set A. What about set V? Set V has the vowels. Are the vowels a subset of the entire alphabet? So we say that V is a subset of A. All right, and now we're talking finally about some specific letters. So what would you say about P? P, again, it's not a set, it's just a single element. So we're saying that P is a part of the alphabet. R is an element in the set that contains the alphabet. And W is an element in the set that contains the alphabet. So you want to be sure as you're doing this that you're using the right symbol. Remember that this symbol is going to be your symbol for an element. And this symbol is your symbol for a subset. And you want to be clear on when to use each one.